Okay, where were we last time? Last time we started the Java versus Python. By the way, assignment 1 is posted with a due date. It's been up for a little bit now. If you think like, well, we haven't learned enough, you're not, I mean, we're going to finish the topic of Java versus Python, which, yeah, it'll help. But really, it'll help. Don't get me wrong. It's absolutely going to help with the assignment, but it won't make or break your ability to do the assignment. I think you are fully capable of doing it now because it's an exercise of doing what you should already know how to do in Python in Java. And if you don't already know how to do it in Python, it's the perfect example of review anyways. These are all concepts. The underlying core concepts are the same as they were in 161 from last semester. And if you're like, but I don't know how to do it in Java, that's correct. That's the assignment, is figuring that out. Okay? Cool? All right. So we did that part, the variables, reusing variables, constants. And the cool thing here, remember, is that constants were, like, you can actually enforce that something is in fact a constant. It can't change. If your code tries to change the value of a constant in Java, Python would let you do that, even though you're being bad. Java won't even run the code if you try to do that, which is cool. And then we were talking about arrays, right? And arrays are kind of like lists in the sense that, you know, you can index them. There's an ordering to them. Not that the elements in the list or array are necessarily ordered themselves, but there is a fact, like there's an index 0, an index 1, and an index 2. Arrays, however, don't have a lot of built-in like functionality. They're fixed size. You really can't do much with them. And then I showed you this, like, well, what happens if you want, like in Python, if I wanted a list of 1,000 numbers, 0 through 999, I could create an empty list and then keep appending to it. Yes, we could do that in Python. In Java, you can't do that with an array. But instead, what you would do is you could create an array with the amount of room that you need, and then add that values, like add the corresponding values to their corresponding indices. That's why I'm saying array at index I is the value I. 0, 0, 1, 1, 2, 2, 3, 3, and so on in that array. And then someone asked the question, are there like default values with what's in the array? And in Java, yes, you'll have default values. If it's integers, you will have the default value of 0 in there. If you make an array of size 1,000, you will have an array of 1,000 zeros when you start. Obviously, I go in here and start changing those things, that's fine. But in other programming languages with other compilers, that's not necessarily true, but for Java, it is. So remember how in Python, you may not have done this, but you may remember that in Python, you can actually index lists with negative numbers. Remember that? Now, you were never really indexing with negative numbers. That was just syntactic sugar. What I mean is, let's just open up like something like Notepad. If I were to say like, can I zoom in? No, zoom. My list at -1. That would be the thing that would be the last thing, right? But now, if I have a list of size 10, what is the last real index there? 9. 0 through 9, that's the 10 things, because remember we count 0. So this is just syntactic sugar for like that. Length of the list is 10, minus 1 is 9, that's the last thing, right? This will work for any arbitrary length, okay? Actually, I don't know what would happen if you had a length 0 array, I don't know, but anyways. It's just syntactic sugar. You're not really indexing backwards. Indexing backwards, not really a thing. What's the thing at index -1? That's not a thing. Even though in Python it makes you kind of look like you can, you aren't really. But, what was I going to say about that? Yeah, and the same thing would of course work if you're like -2. Well, that's the same thing as syntactic sugar for that. And remember, be honest, when I say syntactic sugar, raise your hand if you're like, what is he talking about? Okay, syntactic sugar is just a really kind of annoying way to say like syntax that's just nice syntax for some other functionality. Basically, this versus this. Which one's a little bit nicer syntax? This. Why? Well, I have to write less, and it's intuitive. I know what it means. But what does it really mean? It means that. It's just syntactic sugar. That's all. And that's the phrase programmers use, computer scientists use, when syntax is kind of designed in a way that lends itself to like a nicer syntax, when in reality, it means something a little bit more sophisticated. It's just nicer syntax. That's all. By the way, I completely forgot to mention this earlier. Several people in here last year were talking about last semester, about like programming club or whatever. You probably got the email. If not, let me know. And let me know if you're interested. Programming competition club is like meeting. Like they'll have meetings. And I think the first one is next week sometime. I don't remember what day. I think it's like Tuesday. I can't remember. Did you get an email about it? Okay. If you didn't and you're interested, email me and then I'll get back to you. You would have got emailed this maybe late last week, early this week. I can't remember. But if you are interested, let me know. Yeah. It's not something they'd want you, like, programming competition stuff is kind of a big deal though, so it's not something that you like sign up for and then just be like, I'm not gonna go that day. No, you'll be like blacklisted. Like, don't do that. Cool. All right, anyways. Yeah. This note here, in Java, you can't index negative numbers, right? Why? Well, that's not really a thing, and it was just Python being weird to let you do it with syntactic sugar. Some people don't like syntactic sugar because, like, if you don't know, like, the -1 example isn't too bad. If I'm not a Python programmer and I see the -1, maybe I can figure out what it means by looking at the code in the context. But it's often better, like if I'm not a Python programmer, because that -1 is that's a Python thing. Now your code is unclear to another programmer, right? And when in doubt, make your code as clear as possible. Anyways. Input, output. So lab 1 kind of dealt with this. If we were able to do it on the Thursday. Oh, also, by the way, you didn't switch labs yet. No. Okay, that's fine. So as of now, there are 2 people registered in the Friday lab. And that's fine, but if you were so there is a risk, it could get weird, where they could get a risk of like there's only a few people, they cancel it, but maybe it was required, and then there's a conflict, it gets weird. If anyone in here was like, I really would prefer the Friday lab, switch now. Just because otherwise, like if you want to go from Thursday to Friday, that's fine, that's entirely fine, but switch now before it might be too late and they cancel it and people get screwed over or anything. Not necessarily, they might not necessarily get screwed over, but just in case. Anyways, another thing I was going to say. All right, I/O, input, output. Well, we already know how to output from Java. We've seen it. System.out.println was the one that we used. Println means print line. And system.out.print means print, but don't necessarily go to the next line, right? So this is more similar to how Python's print works by default. Print something out, go to the new line. This, it would just keep staying on the same line until someone like added a new line. Okay? Now, that's what we call like standard output. Okay? Standard input is a little different. Now, I said this in lab and I'm going to say it again. Whenever a programming language, when it's 1980 whatever and they're saying, I want to invent Java. Now there's a reason they want to invent Java. They have something in mind. Other languages do something one way. They want to make a new language because of reasons, and they have well-motivated reasons for that new language. So Java was designed with something in mind, and the thing that Java was designed for was not a lot of standard input, standard output stuff. It's a big, beefy language, okay? It's meant for processing lots of data, building software, and all this stuff. And very rarely, in the terms of like software out there, do you actually interact with your code through a terminal like that. How many of you have done that before this class? one person, right? Two people. It's not very common. And they're the weird ones, okay? So it's not very common. And there we go. Now, mind you, it's good to know how to do that because when we're learning this stuff, we do some of that type of stuff. Now, we're not really going to be doing a lot of that type of stuff in this class. In fact, the only time, when you look back to 161, the only time we really ever, I mean, we wrote to standard output. Fine, that's not weird. That's like logging, right? The only time we ever read from standard input was caddis, because of how caddis works. And there are other programming websites like that where you don't read from standard input. Everything's just a function and then just get the parameters, which is nice, but whatever. Caddis. And assignment 3 when you were playing tic-tac-toe, right? That was the only place we did it. Otherwise, we didn't do that, right? Java, the only time that I can think of right now that you're going to read from standard input is for caddis. So I'm going to show you how to do it. Now, Python, on the other hand, is a language where one of the things in mind, like it's a scripting language. It's a nice, lightweight scripting language that kind of probably became a lot bigger than anyone ever imagined at the time when they created it. And one of the things Python is really good at is this quick and dirty reading input, reading output. Even though you might not necessarily do it very often, it's good at that. It's easy. It does a good job. And that's why, like, if you want to read from Python, you see input, reads from standard input by default. Great, you're good to go. And you look at Java and you're left going like, oh man, what is going on? I've got 2 lines versus 22 lines. Now, sure, some of those are comments and white space, but there's obviously, the point is, there's a lot more going on over here. But, and again, I know we talked about this in lab, but I'm going to say it again anyways for completeness here. But what is really going on here? Well, at the end of the day, the real equivalent lines are these two, between Java and Python. Really, at the end of the day, the most fair comparison is actually showing that, well, it's actually kind of the same. You read input with the function input in Python. Here, we've got this thing that can read, and I say read a line. But of course, there's a lot more stuff going on. So what is that stuff? Well, look. First of all, consider the fact that I've ignored the fact that this isn't a class, and there's probably in a main function, right? Main method. I excluded that for brevity, right? But what's going on here? Well, first of all, I have to import a couple of things to be able to read this stuff. In Python, you didn't need to import anything to do input. In Java, we do. So sure, those are 3 lines of code, but they're not really functional lines of code, right? They're just, they're imports. Then these 2 lines of code here, well, this is just setting up the thing that we use to read. Now, the first thing we're going to do is we're going to create an object called an input stream reader. That's the type of object. And the input stream reader reads from what we call a stream of information that we can read from, like standard in. Standard input is like a stream. Data can come in via the stream, standard in. And I turn it into this input stream reader object. And this object has the ability to read the stream, the data from the stream. However, this is a relatively low-level object. And we don't really like interacting with this object directly because it's a little clunky. You can read bytes and crap, and you don't want to deal with that. So what we immediately do is we throw this input stream reader object into a buffered reader object, which is just basically like a bigger version of a reader with a lot more bells and whistles that's a lot easier to interact with. What's cool about this is a very general purpose object for reading information. Whether it's reading information from something like standard input, like typing in the terminal, hitting enter, or from the internet, a stream of information from the internet, from a file, whatever, it works the same. So it's very general purpose, where input in Python is not. So we create that thing, and then we've got this try, catch. You might remember the exceptions from Python, more on that in a moment. And then we say, just one sec, reader, read the line. I store it. Whenever we read a line, it's stored as, it comes as a string, so I create a variable called the line, and then I immediately print it out. One thing also to note is it's not uncommon to see something like this. Let me zoom out a little. No. I think I need to start bringing a mouse to lecture because there. It's not uncommon. So if you've had me as a prof for programming, you know I'm a big fan of like one line of code does one thing. I really think that's important, right? Now, although I still agree with that sentiment, because this is so common, often what will happen is, like here what I'm doing, I'm creating an object, saving it to a reference variable, and then I'm immediately giving that reference variable to another object, and then I interact with the reader. This is just kind of like the middleman, right? So here, I eliminate the middleman by just immediately creating the new object, immediately passing it to this object, and then assigning it that thing. So it eliminates that. I wouldn't usually write it like that because I like one line of code to do one thing. But this is one of those cases where like, if you did it, I wouldn't be like, I'd be like, yeah, okay, whatever, right? Now you had a question.
Yeah, I'm pretty sure we might have mentioned it once last semester, but it's definitely been a long time since we talked about standard input, output, and error, so it might be a good idea to
talk about output?
Remind what standard input is.
Well, standard input, you mean like, okay, so let me open up IntelliJ. So do you mean like showing? Like, yeah, okay, fine, fair enough. Good call. I'm just going to copy all this. So we're not going to worry about standard error, which is just another standard output, but it's kind of like another area. Okay, IntelliJ. So here we go. Hey, look, last thing I was doing was showing someone exactly what I just showed you, right? Create the input stream, immediately pass it to the buffered reader, and yada, yada, yada. Great. Okay. Okay. Let's get rid of the comments because they're formatted terribly. Okay. So, here, actually. Okay, I'm going to hit run. Okay, run. There's obviously, there's more to it than this, but for our purposes, this is a program. Do you want, okay, sure. What have I done? Okay. So the program's like waiting, wait. Okay, yeah. The program's waiting, and it's trying to read from standard input. This is like the terminal right here, okay? This is a terminal. It's the same thing as like this, right? But instead of being right here, it's opened up inside your IDE, because that's one of the cool things IDE does, is it's a nice consolidated thing. Yeah?
Is the terminal the same as a shell?
No. Very related. We're not going to worry about it. A terminal is really just an application that interacts with the shell. And the shell is kind of like your operating system, which is built around what we call like the kernel. We're not going to get into it. That's like way later. I like where you're thinking though. Anyways, I'm waiting to read from standard input. Hello, everyone. Okay? I'm going to hit enter. When I hit like enter, that's standard input. I'm inputting information into my program. Now what is my program going to do? It's going to immediately print it back out to standard output. So we see, bloop, it just spit it right back out. There's also something called standard error, which would look very similar, but it's actually a different output, and it's basically done for like logging information, where like if something funny and error happened in your code, it would get reported there and not to the output. It's a logging thing. It doesn't matter too much. So we did input and output. If you're like, but how can I really tell the difference? You can't. I mean, I could be silly and be like, one was green, but that's the nature of like this, this terminal. It just kind of showed it like that. So that's just reading input, reading output. Caddis kind of like assumes that the stuff is going to come from standard input and print to standard output. That's all. Yeah, thanks for suggesting that. Yeah, you have a question?
What do you mean by standard?
That's just what they call it. There might be more to it, but let me put it this way. If there's more to it, the importance of the more to itness is so low that I don't know anything. I don't know. It's the standard output.
Is that an opposite?
As opposed to the non-standard output, I guess so, yeah, I don't know. It's not that there's an opposite, that there's other types of outputs you can have. Like you can write to a file or something. You're asking the hard questions today. Wow. Cool. All right. Now back to, here, let's move this over. There. All right. So these are the two equivalent lines, and I just showed you that setup stuff. So we have the imports, and then, okay, we need to make the objects that we use to actually read. Okay, fine. Now, there's also the try-catch thing. You remember from Python exceptions. And remember how exceptions aren't necessarily errors. Exceptions are, and to be clear, we're going to talk about exceptions again a little later. The level in which I need you to understand exceptions is the level in which I'm going to summarize right now. If I have a function, and something funny can happen in that function, I need a way to communicate to the person using the function. If we go back to 161, you remember how we used that divide by 0 example, right? Let's write the function divide. Right? You give me two numbers, I do the division. You know, you give me the top number and the bottom number, I give you back the, what, quotient? No. What do you get when you do division? The answer. You get back the answer. But every once in a while, someone, or for whatever reason, it's possible that the person puts in a 0, right? For somehow the function divide. Imagine I'm writing the function divide, right? Let's write the function divide, right? Def A, B. This is Python. Return A divided by B. There, great, cool, divide. But what should happen if someone divides by 0? That's the peculiar case. That's the exceptional case. Presumably, almost all the time this function is going to be called, B is going to be not 0, because it can't be. If you're using this function correctly, B shouldn't be 0, right? But it's 1991 and I'm writing this function. And you're using this function today, in 2025, and you put in a 0 for B, and something funny happens. And you ask the question, and then pause. You're about to hit run and then pause. What should happen? Well, that depends on what you're doing. If your question is, if you ever think like the programmer in 1991 should have had this behave differently, no. The programmer in 1991 can't read your mind in 2025. But what they can do is say, you tried to divide by 0. Something funny happened. And what should you do about it? Should you crash? Should you ignore it? Should you try again? What should you do? I don't know. Because it's 2025 for you. And you're using this function. So what do you want to do? That's up to you. All I can do is be like, something non-typical happened, something exceptional happened, and I give it to you. And then you, in 2025, can be like, oh, I received this message from the past, 1991, that says something funny happened. If I'm a helicopter reading sensors, and for whatever reason the sensor read a 0 and tried to divide, should the program crash and immediately stop running? Probably not. Should probably just, carry on and ignore it and just, stay in the air. If you're a medical piece of equipment that's about to apply radiation therapy and it tried to divide by 0, we all know when you try to divide by 0, you get close to infinity. Let's apply close to infinity amount of radiation levels to somebody. Should you ignore it and carry on? No. Immediately stop running, crash, stop. Is it a little program where someone's trying to enter and they're like, hey, what's going to happen if I do 0? Well, maybe you just say, okay, input information again, try again. What do you want to do? It's up to you. But the point is, I don't know. So that's what this is, the try, catch. Try to read the line, but if something funny happens, what are we going to do? Here, we're just going to say something funny happened and we carry on and we ignore it. Why? Because it doesn't matter for our needs. Now, the way we're using this, it would be very remarkably unlikely that an exception would ever be thrown. Like, we can't really make an exception happen here. It'd be very strange. I don't even know how you would. But the programmers, unlike in Python, if someone wrote code that might throw an exception, me as the programmer can choose to be like, yeah, I know it might, but whatever. I'm not going to put it in a try catch. If it crashes, it crashes. If the exception is thrown, it crashes, whatever. I don't care. But in Java, Remember, Java gives the programmers a lot more tools and flexibility over the control of their code. So Java provides a way for the programmer in the past to say, not only will this code potentially throw an exception, if you're using this, you must put it in a try-catch. You must. And that's what they did here. So that's why we must put it in a try-catch. Even though it would be really weird for an exception to happen here, we have to do it. Because the programmer in 1990 whatever, when they wrote this code, said they must deal with it. Meaning I have to put it in a try-catch. Now, there's a bit of an exception to the rule. What you can do is we can cheese this a little bit, where we can go up to our main. By the way, this would work if this was nested in other functions as well. But we can go up to our main, or whatever function that our code is in that we'd have to put the try around. If we don't do a try, what we could do is go up to our definition, or the definition of our function, and add this throws exception at the top, which basically means, okay, look, I'm not going to deal with it, but whatever function called me has to deal with it. This is effectively what the programmer of the read line put in their function read line. If you go look at it, there, let's see if we can actually see read line. Read line. See, look, there we go. I'm literally looking at this, like Java's read line method, okay? And we can see that it throws an IO exception. Because that's there, it must be in a try-catch. Unless we just pass the buck by immediately adding this line to our function, which means whatever function calls this one must put it in a try-catch. Now, if you remember, what calls main? A human. When they hit run on their program, main runs. And if we have an exception that ever gets to main and was never dealt with, the program crashes. So it's kind of like a way to cheese the IO exception by doing that. Now, if we had main call method A, okay, that called read line, and we put method A had that throws IO exception in it, where we call method A in main must try catch it. Or, once again, pass the buck by adding this to the top level. If that made sense to you, great. If it didn't make full sense to you, it's not that important right now. I'm just explaining it, okay? Function and methods. So any questions about that IO stuff? The last lab was getting yourself familiar with it. Good. You might also want to get yourself familiar with, as described in the lab, something called scanner. Okay. Methods, functions and methods. So as we said before, there's no such thing as functions in Java. We can have static methods, which are effectively functions, and often we call them functions, but if you wanted to be a stickler, really it's not a function, it's a static method. So here is a function in Java. Def sum function. It's got two arguments, or two parameters, colon. What am I doing? It just calculates the sum and returns the value. Great. And then down below, I call it. Call the function, result, some function, whatever, right? This should be like, yeah. If this confuses you, come talk to me, okay? If we look at Java, well, the order is different. Doesn't really matter, but by convention, typically, you see main near the top and these down below. I'm making a function. Why is it a function? Well, it's a static method. Why is it static? Because I said static in front of it. So in my main, that's where I'm calling it. So these two lines here, 7 and 8, would be like lines 4 and 5 here. Okay? Here is the actual function. So it's a static int sum function. It takes two parameters, a and b. It calculates the sum, stores it in a variable, an integer variable called c, and it returns the result. What's going on there? Well, first of all, static. Static needs to be there in order to call the function or the method like this. Otherwise, I would need to make an instance of a sum class object and then invoke the method on an instance of the object. I know. Static is, like I said before, static is like the weirdest one to wrap our head around at this stage. For now, it's okay to be like, okay, I'll just go with it. Yeah.
So you put the declare
declaring the function below calling
Yeah.
the function?
That it doesn't matter if it's below or above. In some languages it will. In Java it doesn't. It's got a two-pass compiler, meaning the first pass is it just makes sure everything is like, yeah, that exists, that exists, that exists, that exists. And then it goes and does it. So does that answer your question?
Yeah.
Okay. His question was, this was below. You're calling it before it's defined. It doesn't matter in Java. Some languages it would. Like in C, if this is 19 whatever, 1980 in C, it'd be like, what the hell's that? And you'd have to kind of do something special to make it work. But in Java, Java's cool like that. So it's static, it's static. I need, this int tells me the return type of the function. This is a function that will give me back an integer. I need to specify it. And the reason for that is on this line, Java knows, oh, this is going to give me back an integer. Why? Because it says it will. Therefore, it's safe to take the integer and store it into an integer variable. So it's an integer. It's going to take two integers, a and b. I realize over here I could add type hints, but the type hints don't really have any functional meaning to Python. It's just like self-descriptive code, but remember in Python, like I could break the type hints. I didn't actually have to follow them. In Java, if I try to give this a string, it won't run. It won't even compile. So some function, mind the convention. We use camel case, not snake case. Int a, int b, open squiggle. Just add them together, return the value. Mind the semicolons as well, and then close brace to close off the function. Here, I gave it two values. These are the literals, 1 and 2. If you don't remember literal is just the fancy way to say it's literally 1. It's not some variable that has the value 1. I just typed a 1 in there. Yeah?
Is there a reason for the syntactic convention between the two?
Like, there might be, someone a long time ago probably thought long and hard about why are they going to go with this convention. I don't know. I really don't know. This is a common convention from like, so there's kind of like a bit of a history lesson to some of this, and it depends on like the source, like where the language is kind of like evolved from. Like if you go to like, so Python has the PEP standards. I honestly don't remember what they stand for. PEP, someone look it up real quick. What does PEP stand for? Probably some Python something practices, whatever. Some of these standards that people set out, and it's like universal. You're following the standard or you're not.
Python enhancement proposals.
Python enhancement proposals. So that's where the standards were set. There's like this master document that says like these are the rules, right? Java has like these are the conventions you follow, and if you're not following it, you're breaking the conventions. If you go back far enough, before there were conventions in other languages, like you look at C++, and you're like, well, what is the common convention for C++? There is a more popular convention, but C++ is from a time when like things like that weren't really thought of as hard. So you have competing conventions. So then like Java, which really like took a lot from C++, Python did too, don't get me wrong. They followed probably whatever was the most popular at the time. And that's where that came from. But how that evolution really got to where it is, I don't really know. And it's kind of interesting to think about. Yeah.
How much do you care about that?
How much do I care? A lot. How much does everyone care? A lot. The Java police will come and get you. All right? I will call them myself. Anyways.
Wait, so snake case is older than Python?
I don't know. I don't know. I really don't know.
Name-wise, it sounds
Yeah. There are other conventions too that other languages kind of follow. Like here's one that like here's one. Like if, here. See how like the brace is like this? This is also, so in Java this is non-standard, but like if it was C#, this would be standard, right? Where you put your braces always on the next line. Like this, right? And you might say, well, why? Why would you do such a thing? What were we going to say?
How much would you care about something like that?
This one, I'll only get a little mad about. But like if you're following, like if your class names don't start with an uppercase, oh man, I'm gonna lose sleep. I'm gonna go to bed thinking about what you did to me, you know? This one's not so bad, right? Some languages this is more common or standard. Now you might say, why? Well, first of all, that extra white line is not uncommon when you have a function. Like white space could be nice for visual clarity, and that brace, whatever, it takes up the space on that white line. And another thing that's nice about it is like you could always find in a vertical line, exactly, like if I follow, there it is, where if it's like along over here, I might have to go up and over, right? So there is some value to it, don't get me wrong. Don't do it though, right? You'd be kind of breaking your conventions. By the way, as a side note, your IDE will enforce conventions for you. Like if you save, but you have to press something to make it happen. And you can make it, no, there's a button you can press. And you can make it so whenever you save it auto formats, which is kind of cool, but that's neither here nor there right now. Just an interesting piece of trivia. What else about this? Yeah, that's basically it. Yes?
Is there anything in Java that you use snake case for?
Constants. But they're also all uppercase.
Yeah, which it's too fun not to share. That's called screaming snake case.
Screaming snake case? Nice. Okay. I get it. Makes sense to me. I'll probably remember that. All right. In Java, you have to say what the return type is. Parameters have a type. We have to specify. The function is static, which means the function is not a method. Although it is, it's a static method, which we say is a function, but really it's a static method, whatever. In other words, it's not a method, so we can just call it. We don't need to call it like on an instance of an object. This will get clearer as we go. But remember how like in the country catalog assignment, if you had like a country catalog and you wanted to add something to it, the method add, that was a method, not a function. You would have to say like my country catalog dot add, right? I didn't have to have an instance of an object to say some function here. I could just call it, okay? What you could do, never mind, it doesn't matter. It's not required in Java, but one could in Python. All right, this function is called with main, but is written below main. This is not required in Java, but it's something one could do. In Python, the interpreter needed to know the function existed before it can be referenced. Okay, cool. Now we have instance methods. So not functions, methods. Or not static methods, instance methods. If you don't say static, it is instance, okay? So for instance methods in Java, there is no need to include self in the parameter list. Remember how in Python, if I wanted to make a method, I would say def some method. This is in some class. I don't know what it is, but it's in some class. The first thing in the parameter list must be self. Although we learned it doesn't need to be called self, it just needs to be consistent, but it needs to be called self, right? So some method, self add me, and then self dot some instance variable, whatever, add me, right? We needed that self to, whenever like it referenced an instance method or an instance variable, whenever it was something that belonged to an instance of an object, we needed that self reference variable, right? In Java, you don't. Okay? You can. It's great for resolving ambiguity, but in Java, we don't need it. So if I have some method, public void, it's void because it doesn't have a return. Usually when you don't see a return, your function is side effecty, or your method is side effecty, and that's fine for some objects. Some method, int add me, some instance variable. Notice I don't have self, plus equals add me. Now, the equivalent keyword, even though in Python it's not really a keyword self, it's just by convention everyone calls it self, and if you don't call it self, the Python police come for you. In Java, it must be called this. It's this. So instead of self, it's this. You'll see it. You'll be fine with it. It won't freak you out. It'll make perfect sense. Just wait till you see it in the right context. It'll make perfect sense. It's public. Usually you specify if this is a method that belongs to some class, it's public if you want to be able to access it. You might say, how come I didn't have public or private in front of this? It didn't really matter here. If you don't write something, it's called public or package private by default. It doesn't matter for our needs. Instance methods. Yes?
Is it that because you're running the main class? So it's like
It's not, I could have written public, I could have written private, I could have written, there was no reason to have it. Now, within the context of how that would have been used, not only for an example, but like how one would use it in this way. Here, you could make a similar argument, but at the same time, this would be in some class that presumably this would be a public method that you'd want to access from outside, so it really would make sense to be public. This is something that if you have enough experience, you'd be like, yeah, that makes sense here. At this stage, if you're like, that makes perfect sense. That's weird to me that it makes sense to you at this stage, but cool. It would be, my expectation is that you're kind of left going like, I still kind of don't. I know, that's fine. It's not going to make sense until we see it in its correct context. Right now, I'm just blitzing you Python versus Java stuff still, okay? Visibility modifiers, speak of the devil. Visibility modifiers. In Python, the convention is to add an underscore to the beginning of any attribute or method name if, in Python, there's a convention of adding an underscore in the beginning of an, this is done to indicate if the attribute or method is not supposed to be accessible from outside the class, right? Basically, like, if I'm interfacing with my car, there's a lot of functionality in the car going on, right? But I don't need to care about that. So all that functionality is private. All the functionality I interact with as the driver would be the public things, like gas, brake, put it in gear, right? Steering wheel. Those would be the public things, but like fuel pump. Okay, obviously there's some functionality going on in there, in my car. Fuel pump's doing its job, right? But me as the user, I don't interact with that directly. I interact with the gas pedal, and that functionality interacts with the fuel pump. So it's private. It's important for the operation of the thing itself, but not for how I interact with it. In fact, I don't want to know about it. Why? Don't confuse me. Don't give me crap I don't need to see. That's the idea. I want you to get an intuition at this stage, not a complete understanding. So don't worry, we're going to see a lot of this. In Java, we have explicit control over this with keywords like public and private. In Python, we didn't use keywords, we used the convention underscore, which meant it's not supposed to be accessed outside of the class, but you could if you wanted to. In Java, if I say private, you can't. Java won't let you. That's good. It gives the programmer more control over how the code is used. Java will even produce a compiler error. So in Python, def, you can touch me, whatever, some method. Underscore, do not touch me. That means don't use this method, okay? You can touch me might be able to call self dot underscore do not touch me. That's fine. But if I'm outside this class interacting with this object, I'm not supposed to access it. But I could. Python lets you. I'd be breaking the rules, but I can do it. In Java, the same idea, public, I can touch that. I can't. If I tried to, Java would say, nope, not even going to. It's not even that Java won't run it. Java won't even take your code and compile it into something that can run. That's a good thing. You don't want your code to be doing things it's not supposed to. It's better to have code not run than to run wrong. Okay? Questions, thoughts, concerns, comments over that? It is not my expectation that after this blitz explanation that you understand this completely. It's just, I'm giving you the insights and intuition, like where we're going. And then, like I said, when we start to see this in the context in which how we would really use it, in like a bigger context, it'll be a little clearer to you then. That's when it'll click. Okay, temperature converter. You might remember this, right? We did this back in did you have a question? No. Okay. We did this back in Python. Fahrenheit to Celsius, right? So here's the function. How do we do it? Well, it takes some Fahrenheit, does the calculation, return, there we go. Here it is in Java. Now, remember the division on like 2. That should say line. Someone can fix that. You want to do it? Someone can do that. On like 2, that's supposed to say line 2. 5 divided by 9. What's 5 divided by 9? Right? Point. Yeah. To me, the answer is 0. Right? It's 0, remainder 5. But it's 0 because it's an integer. If I have an operator that takes 2 integers, I should get an integer back. Now, if you're used to Python 3, which is what you're used to, you get back the float. You get back 0.555555555. That makes so many people mad. All right? Because in Python 2, and like every other good high-level programming language, this is integer division, meaning you get back an integer. If I were to type that into Java, five divided by 9, I'm going to see, eventually, 0. If I want to do non-integer division, I make them not integers. I make them floats. Now they're the literals, and it'll work just fine. It's context sensitive. Division works one way with integers and another way with floats. Now, do note that really only one of them needs to be a float, because Java will be smart enough, okay, if one's a float, we don't want to lose precision, so we'll assume it's floating point. But there we go. If you go back to Python, 5 divided by 9, if you really wanted integer division, use a different operator, //. Just know that if you're like, Java's weird, no, Python was the weird one, by the way. So the solution here is, yeah, turn them into floats. When in doubt, if you want floating point division, do floating point division by dealing with floats. Questions about that? This might get you as a bug in your future selves. Just after you spend hours figuring out what it was and you go like, integer division. Just think of me right now laughing at you. Because I warned you. Yeah?
What if, like, you use it like double, whatever the name, equals 549? Like you declare it?
Oh, like if I declared it, it won't matter. So I can store an integer and a double, it's fine. But like the type checking, it'll do it, but like you messed up.